channel. So in the previous video, we have talked about slowly changing dimension, where we know how data changes over time and how we can handle those changes using SCDs type, that is type 1, type 2, type 3, and other types as well. Now, in this particular video, we are going to talk about different types of dimensions, and this different types are really useful when we design our star schema pattern, when we design our snowflake pattern, when we design our data model, when we need to improve our query performance. We need to have the idea of this different types of dimension. So moving forward, we have different types of dimensions available, that is confirmed dimension, junk dimension. We already talked about slowly changing dimension. Then we have outrigger dimension, calendar date dimension, role play dimension, shrunken, degenerate dimension. We are going to each of this dimension. We are going to dive deep into each of this dimension, how we can identify those dimension. So for this particular dimensions, we have this particular schema where we have this order fact table, and with this order fact table we have this customer, product, store, date, promotions, flag indicator, region. So here you can see region is connected with the store dimension. Dimension can be interconnected with each other as well. So these are the dimensions that is associated with this order fact table. We are going to identify each of the dimensions type, and the above two tables, that is invoice and payment tables, these are the supporting transaction table that is tightly coupled with order fact table. So we are going to use this example and we will understand the different types of dimensions with this example. Moving forward, so let's first talk about what are confirmed dimensions. So confirmed dimensions are the dimensions that have the same structure, meaning, and content everywhere. So why are they important? They bring consistency to your data model. It can be reusable. It can be enable cross-functional analysis, scalability, easier to maintain, and it can be extendable as well. So if I talk about the definition of this confirmed dimension, so here you can see the confirmed dimensions are those that remain consistent in structure and has the same meaning across all the fact tables. So let's say we want to analyze total sales, that is order fact table, invoice trends, or payment success rate. To compare these KPIs meaningfully, we need dimensions like customer, date, and product. Now, if this dimension are structured the same way across all the fact tables, we can slice and dice our KPIs seamlessly. Let's look at our schema. So in our schema, we have three fact tables, that is order, invoice, payment, and several dimension table, that is customer, product, store, region, date, promotion, flex indicator, correct? Now, if I talk about how we can identify which dimensions are confirmed, meaning they are used across multiple fact tables with consistent structure. So even though some dimensions are used only in one fact table, but can be reusable, has the same structure, that can be our confirmed dimension. So in our schema, we have this dimension: customer, product, date, store, promotion. Now you can see customer is used in order and payment table, product is used in order fact table, date is used in order table, invoice table, payment table, store is used in order fact table, promotion is used in order table. Now, for example, if I talk about customer dimension, the customer ID is going to be similar across all the fact tables. It is not going to be changed. So it can be one of our confirmed dimension. Product ID is going to be similar across all our fact tables. It is going to be our confirmed dimension. Similarly, date, similarly store, similarly promotion. So if the dimension has the same structure and has the same meaning across all the fact tables, this can be considered as a confirmed dimension. Now, how we can identify confirmed dimensions? To identify confirmed dimensions, we have several criteria. We can check if the dimensions are getting used in several facts table. It If the dimension have the same structure, if the dimension has a consistent meaning across all the fact tables or across all the domains, then we can consider that particular dimensions are confirmed dimensions. Okay, so this is for confirmed dimension. This is how you can identify the confirmed dimension. Moving forward, let's talk about junk dimension and why it matters. So before explaining junk dimension, let me tell you what are the problems that we face without junk dimension. So let's say we are storing some flags directly in your order fact table. Here is what a few records might look like. So here you can see order ID, customer ID, product ID, date ID. Now return flag, gift wrap flag. Now return flag, yes and no. Gift wrap flag, yes and no. Very low cardinality. and very less distinct value, only yes and no. These two are the distinct value. Now, if we add these values to our fact tables becomes bloated with descriptive flags, and it is harder to maintain and query. So what we can do instead is we can create a junk dimension. We have all these flags into a separate dimensions called flag indicator, the flag indicator that I have shown you earlier in my schema design. So here you can see we have created one junk dimension table, that is flag indicator, which contains return flag, on wrap flag, express delivery flag, fraud suspect flag. So if I talk about our updated order fact table, so here you can see we have replaced this return flag, gift wrap flag with this flag ID, so that our fact table don't get bloated and we get faster query performance. And even in the future, if a new flag gets introduced, we can add it into our junk dimension table without updating our order fact schema. So that is one of the advantage of junk dimensions. So what are the benefits of using jump dimension? We get a cleaner fact table. We have seen through the example. We get the better query performance. We can reuse these junk dimensions, and it provides us the flexibility to add new flags without altering the fact schema as well. Now, how to identify junk dimension? So if you get a dimension that contains low cardinality, that is non-additive, used for filtering or reporting purposes only, now that can be considered as junk dimension. So this is all for the junk dimension. Moving forward with outrigger dimension. So outrigger dimension is a dimension that links to another dimension instead of directly to the fact table. So in our particular schema, we have seen this store dimensions links to region via region ID. So this is what we called as outrigger dimension. Dimension to dimension link, adds context, avoids fact table bloating, supports hierarchies. So region provides additional context like country zone, but isn't directly tied to any fact table. This is the dimension to dimension link. So this is what outrigger dimension means. Now talking about calendar date dimension. So most of you know that the date dimension is very crucial because it is getting used in almost every fact table where we require time analysis. So for almost every KPI, sales, revenue, returns, payment is tied to time. We need to know when something happened to analyze trends, seasonality, growth, and performance. But raw dates like don't tell us much. That's where calendar date dimension come in. So in our schema, we have date dimension with the following field: date ID, full date, day, month, quarter, year, and fiscal report for fiscal period mapping. So these are the calendar date dimension. So how to identify calendar date dimension? Risk time attributes used in time analysis, multiple rows, preloaded table, supports flag optional, can include his holidays, weekend, etc. So that's how we can identify calendar date dimension. Even if we don't have a date dimension, we can create one date dimension so that we can use it across other tables as well, because it is very crucial, because most of the facts are tied to time. So this is all about calendar date dimension. Now talking about role play dimension. So in dimensional modeling, a role play dimension is a single physical dimension table, but it plays several roles in multiple fact tables. Talking about role play dimensions. So suppose a actor is playing multiple roles in a movie, that can be considered as a role play dimension. So in our schema, we have date dimension using multiple roles across fact tables. So we have our date dimension, date ID, full date, day, month, quarter, year, fiscal report in our schema, in our example that we have used. And this particular date is used in order fact table, invoice table, payment table. And if I talk about order fact table, so here you can see role: order date, ship date, delivery date. So it plays three different role in order table, that is order date, ship date, delivery date. If I talk about invoice table, it is playing the role of invoice date. If I talk about payment table, it is playing the role of transaction date. So this particular date dimension is considered to be as the role play dimension because it is playing several role in our fact table. Moving forward, how to identify role-playing dimension. So here you can see the criteria: same table, different meaning, multiple foreign keys, semantic clarity, avoids duplication, supports lifecycle analysis. One dimension used in multiple roles, date used for 5 timestamps. Fact table has several links to same dimension: order, date ID, ship date ID. Each role has a distinct business meaning: order date versus delivery date. Prevents creating multiple date tables, one date table reused. Tracks stages of process: order, ship, deliver, invoice, pay. So this is all about role play dimension. Now talking about shrunken dimension. A shrunken dimension is a simplified or aggregated version. You have a base dimension and you shrunk that dimension to at a granular level so that you get faster performance. So why do we need them? So let's say our business wants to track sales by zone instead of individual stores, performance by country instead of a specific region. So if your main dimensions like a store or region is too detailed, it can overwhelm dashboard or slow down queries. That's where shrunken dimension comes into picture, that give you a clean, granular, high level view of your data, which can increase your query performance. So here you can see in our region, we have region ID, region name, country, zone, and in a store, store ID, store name, location, region ID, manager name. But we don't want that much information. Now imagine we want to report sales by zone only. Instead of joining through a store, region, zone, we create a shrunken region dimension, that is zone and country. So this table is smaller, faster, and perfect for executive dashboard. So this is all about shrunken dimension. Now moving forward, how to identify shrunken dimension. So here you can see the criteria, subset of attributes, higher level granularity, derived from base dimension, used in dashboard, improves query performance. Wherever you want this criteria, you can think of shrunken dimension. You can create a dimension on the basis of your base dimension and include only necessary attributes that is required. So this is all about shrunken dimension. Moving forward, degenerate dimension. So degenerate dimension is a business identifier like an invoice number or order ID that stores directly in the fact table but doesn't link to any dimension table. It is useful for reporting and filtering, but it has no descriptive attribute, so it doesn't need a separate dimension. So let's say you want to filter by invoice number, filter by order ID, track transaction using ticket ID or receipt ID. Those identifiers are essential for reporting, but they don't describe anything. They are just unique keys. Creating a separate dimension for them would be overkill. So instead, we keep them inside the fact table, and that's what makes them degenerate. So this, if I talk about our schema design, so inside invoice fact tables, you can see we have invoice number, order ID, invoice date, billing address, order fact table, order ID, customer ID, product ID, promo ID, quantity. That's it. So here invoice number is a degenerate dimension in the invoice table. Order ID is a degenerate dimension in the order table, even though it is also a foreign key in other fact tables. These fields are useful for filtering, grouping, and drill downs, but they don't link any dimension table or carry descriptive attributes. So how to identify degenerate dimensions? So criteria is very simple. Unique business identifier, no attributes, is stored in the fact table, used for reporting purposes only, doesn't belong elsewhere. So this particular criteria fits the degenerate dimensions. So here you can see the description as well. And in the example, invoice number, order ID, no attribute, doesn't have name, age, type, status, just a ID, lives directly in the fact table, commonly used in filters or drill down, shows invoice, and not a part of customer product or date dimension, purely transactional data. So these are the different types of dimensions that we should know, because it is very useful when we create our data model, when we create our star schema design patterns. So that's it for this video. If you are new to the channel, please like and subscribe to this video. I will come up with the interesting video later on. Till then, thank you for watching.